So the fifth unit of testing of material is other testing methodologies. So the major thing we are going to cover in this fifth unit is various other testing methodologies like spectroscopic methods, diffraction techniques, and the various devices which is scanning calorimetries and plasma coupled plasma techniques. Everything will be covered in this other testing methodologies. So first thing is the thermal properties. So in this first half of the unit deals with your thermal property analysis. So various thermal properties will be of thermal conductivity, specific heat, thermal expansion, thermal stress. These can be studied with the help of some devices called as differential scanning calorimetry, dilatometer, differential scanning thermal analysis, dynamic mechanical analysis, thermomechanical analysis, thermogravimetric analysis, and thermo-optical analysis. These 7 methods will be used to study the material properties when subjected to some temperature. So previously we have not yet seen any consideration of temperature in order to view the physical or chemical or mechanical properties of a material. But in this case, we are going to consider temperature as one of the parameters. Since metal will be subjected to a high temperature, means it start to expand or elongate, or it can deform from its original shape. So that consideration is taken into account, and you are going to know about the concepts behind this thermal properties study with the help of these methods. So first one is your differential scanning calorimetry. So this differential scanning calorimetry is used to measure the amount of energy which can be observed, that is amount of temperature that can be observed by the specimen and the released from the sample with respect to a time. Okay, so this DSV is used to calculate the thermal properties such as melting point, heat of reaction, glass transition temperature, and heat capacity of a particular specimen, particular metal or material. First one is your differential scanning calorimetry. Basic principle is it consists of 2 types of material, that is sample and reference material. The two material can be maintained at same temperature during a particular time duration. For example, for 5 minutes or 10 minutes, you are considering the experiment, means you are conducting the experiment, means that the 2 sample and referential materials will be kept for a same thermal event, that is subjected to 100 degrees Celsius for 10 minutes. If you are taking that as a consideration, means this sample and reference material will be maintained at that particular state for in an equal manner. That is, next you are going to study the energy which is required to maintain this temperature between the sample and reference. Once the sample will have some temperature absorption and reference will have some temperature absorption. So you are going to maintain the energy as temperature that can be used to maintain both the temperature as the same value with the help of this principle. The unknown sample quantitative measurement can be obtained with the help of this temperature difference. So there are various types of DSE available. So first one is your heat flux, second one is your power compensator, third one is your modulator, fourth one is your hyper, fifth one is your pressure based DSE. So here today we are going to see about heat flux and power compensator DSE. So first one is your power compensator DSE. In this case, the thermal energy, that is the temperature is applied to the sample and the reference material separately. So each devices, each specimen will be calculated, that is temperature can be measured with different functions of temperature. So yeah, there won't be any same consideration for sample and specimen temperature. So these are the devices which is required to do this operation. So first one is your sample holder, second one is your sensor, third one is your furnace, fourth one is your temperature controller. Sample holder will be used to hold the sample. Mainly the sample used will be aluminum or platinum pans. That holder will be made up of aluminum or platinum pans. Inside the holder, the specimen can be placed. Next one is your sensors. The sensors will be made up of platinum resistance, and the furnace will have some separate blocks for sample and preference cells, temperature maintenance, and temperature controller. In order to maintain the temperature in both the specimen and the sample, you are in need of some controlling devices. That is a temperature control device. Next one is your working. So initially you are going to measure the energy which is used to maintain both the sample and specimen temperature as same. That energy can be measured. So since the energy can be measured, the difference in the energy can be measured means this DSC will have two distinct heating units. The heating units are very small, which can be easily heated and cooled, and you can maintain the equilibrium state. Equilibrium state in the sense same state. Since you are going to apply some temperature to the specimen, so each can be monitored regularly in a frequent period duration. The instrument which is connected to that particular sample and specimen is used to record the energy change or energy required to maintain this both the temperature as same. That can be used to record that data. After recording these data, it can be analyzed to find how much amount of energy is consumed during each temperature change. That can be calculated with the help of this. When this type of 100 degrees Celsius is subjected to a specimen means how it reacts. That can be studied with the help of these power compensated devices. So the name indicates power compensated device, DSC. Power compensated in the sense how much amount of energy or power which is required to maintain the temperature same in both the sample and specimen, that can be calculated, and with the help of that parameter you are going to study the temperature, thermal stress, and melting point and heating point of a particular material. Next one is your heat flux DSC. This heat flux DSC is heat flux, that is, in the previous case the power will be measured. Here the heat flow into the sample and reference will be measured, and that changes can be made as a constant. So this is the experimental setup for heat flux DSC. This heat bath will be maintained this place. Beneath the heat bath, the sample will be placed, and one side the reference will be placed. Since the heat sink will eliminates same heat amount of heat to both the sample and reference, this sample will be having of some certain temperature absorption, and the reference will have some separate temperature absorption. Both can be used to find out the difference between these temperature absorption with the help of this heat sink. The heat sink is, once it lost the some amount of heat with the sample and some amount of heat with the reference means, the temperature, for example, it have to be maintained under 100 degrees Celsius means, if some amount of heat will be observed this with this sample and reference, it start to reduce its temperature range. So external power is connected. The power will be used to increase the range. For example, after observing some power, it reaches 90 degrees Celsius. In order to maintain this heat sink as a constant to 100 degrees Celsius, some amount of external power is required in order to increase the 90 to 100 degrees Celsius. So that power consumption can be calculated. After calculating this, the depicted results will be matched with the temperature, melting point, thermal stress, various thermal properties can be studied with this help of this heat flux DAC and power compensated DAC. This is the arrangement of heat flux DAC. So this external will shows the chamber, heat chamber. That heat chamber, inside the heat chamber, sample and reference will be hold in the some chromal disc. The disc is made up of platinum or aluminum. So with the help of the parameters obtained, we can mark the temperature versus heat flow rate into a graph. We will obtain the glass transition temperature, crystallization temperature, melting point, and cross-linking and oxidation of a particular material. The various states can be studied with the help of this DAC curve. So these are the various factors which affect the DAC curve. Instrumental, sample characteristics factors. So application of DAC, when you consider this application, it is used to study the oxidation state, and the transition temperature from amorphous to crystalline form can be studied with the help of how much amount of temperature will be required to convert that particular sample from amorphous to crystalline state. That can be studied with the help of this DAC technique. Either it may be power compensated or heat flux DAC.